Hi guys, welcome to another video. Today, another video in the 100 series that I've been doing, right? So the 100 are 100 integration extension 2 questions that Jim Coroneos in the Coroneos textbook that he used to do had 100 nice questions for people to practice. We at Next Education then put together the next 100. So if you would like a copy of these, email us and we'll flick it through, and then you can have a crack at it, right? So this series is basically designed for me to go through randomly, right? Depending on how I'm feeling, depending on what sort of theme I'm trying to present, just picking questions for us to do. So today I'm picking 2 questions from the Coroneos 100, right? Which are trig related, right? They look fairly similar, right? Like when you sort of boil down, but the approach and the approach seems like we're similar, but the outcome is a bit different, right? So let's start with the first of the 100 that I'm going to do today. So this one here, right? So looking at this, there's a lot of trig here, but what really dawns on you, right, is that there are like sort of trig identities that you can explore, right? That's double angle, and if there's cos squared and sine squared, so some of the things sometimes you might want to go, which one do I want to make the subject, right? Now, I think if you're sort of on top of your identity game, right, you basically know that that's 2 sine cos, right? And once again, if you're on top of your identity game, 2 sine cos. Now, because it's a fraction, something you should explore is reverse chain rule is the easiest and most obvious thing to explore, right? So the question is, if it's 2 sine cos, if you know your theorems, right, or your identities, right? If you let u equal to something, right, over here, and the derivative, right, I want to be like 2 sine cos, right? Yeah, I want the derivative to be 2 sine cos. I mean, if you think about it, right, it feels like if I had sine squared there, the subject, because the 2 comes down and derivative, of course, the chain rule applies. I sort of get that, right? In other words, if I can make sine squared the subject, right, downstairs by removing cos squared, I'm there, right? I'm there. So in this one, he actually replace cos squared with 1 minus sine squared, right? Yeah. Let's see where that takes us. So you go, that becomes integral of 2 sine cos on top, right? I'm going to reverse this chain rule, right? So that's like 3 plus 4 of these. Yeah. So then I get, now let's take that to the next step. So 2 sine cos. Does that become cos? 3 minus 3 plus 4, perfect. That's sine squared. That's cool. Because now, in this case then, right, I can say that this here is my function. And because that 3 goes away, the derivative is upstairs. Right? I can fit it into the ln integral, right? When I reverse that chain rule. So that's integratable to 3 plus sine squared x plus c, right? Now, if you're amazing, you know that this guy's positive, right? Sine squared is positive, so this guy's positive. So you don't actually need the absolute value if you didn't want to, right? And I think that's Coroneos' answer. Guys, how's that? Nothing too hard about that, right? Apart from applying some identities. I guess some of us might just get stuck and you don't appreciate this, but I guess if you sort of understand or recall or practice or experiment with letting u equal to sine squared and the derivative is, that's it, right? That's how you do this question. Now, let's do one more from the 100. This one here. Now, this one here has less stuff. So even though it looks cleaner, it's probably a little bit harder because the other one, I had direction. I had sine double angle on top to begin with. This one here, I mean, 1 plus cos squared, I don't really know what identity to use. Now, so obviously, option 1 is to use t result, right? Yeah, option 1 is to use t results for this one. And, it can work. But for this specific example, right? Maybe, which one should I do first? Oh, let me do t results first, right? Let me do t results. Yeah. So with t results. Now, with T results, you have, I guess, choices, right? You got, now let me see if this one works. Yeah, so I got choices. So you can either go and use let t equal to 10x on 2, right? The other way is t equals to 10x, right? Two types of t results to explore. This one here, dt, oh sorry, dx rather, would equal to 2 on 1 plus t squared dt, right? This one here, dx would equal to 1 on 1 plus t squared dt. Yeah. This one here, obviously, you start using double angles for your t's, while this one here, you use single angles, right? Now, the reason why I highlight that is the easier one is actually this one, right? If you sort of use identities to help you here, right? Because I know that, let's explore this, right? Cos, you know, I know that cos using double angles of cos, right, is equal to, what's that equal to, guys? Cos squared. Now, cos double equals that, so it'd be like 1 plus cos double on 2. Is that right? Yeah. So if I sub that in, I sort of get, let's see what I get. I put 1 there. 1 plus cos 2x on 2 dx. Yeah, t results actually has quite a lot of steps, right? So we're going to do it over here. Yeah, make it a bit neater. Guys, common denominator and chuck 2 on top. So you sort of get like 2 on top of 3 plus cos double dx. All right, now let's replace that with t result. That's the cos version. This guy gets replaced with 1 over plus t squared dt. Yep. Now, let's see if this is right. Yep. Then you get 2, another set of common denominator required expressions. 1 plus t squared dt. Common denominator that. So you get 2 all over 3 plus 3t squared plus 1 minus t squared all over 1 plus t squared. Meanwhile, over here, you got 1 plus t squared. That's nice because that cancels out with that. And then you're left with hopefully something integratable, right? Let's see. 2 over 4 plus 2t squared. Yeah, that's integratable. Let's cancel that out. So it becomes like 1 over 2 plus t squared. Tan inverse, is that right? Yep. So that's like 1 on root 2, because a is root 2. Tan inverse of t on root 2 plus c, and then sub t as 10 in there, right? 10 2 plus c. Guys, that was a bit long-winded, right? Yeah, that felt like a stretch and a half, right? Now, for this question, actually, there's a nice little algebraic sort of method to this, right? Yeah, or identities, right? So number 2, use identities, right? Identities. Yeah, that's sort of cleaner, right? So, for example, if I had 1 over 1 plus cos squared, right? Yeah, because cos squared isn't really a nice thing to integrate, right? Sec squared is, right? So sec squared is. So I'm going to try to divide everything by cos squared, right? Yeah. So divide all parts by cos squared. Yeah. Sec squared is a nicer expression, right? That becomes like the top will be sec squared. Here you get sec squared plus 1, right? If I divided reading top and bottom by cos squared, right? You get that. Now, what's the relationship here, right? I know that the derivative of tan is sec squared. And right now I have sec squared on top. So if I can make the bottom an expression with just tan, I can reverse chain rule this, right? So guys, we know that sec squared equals to 1 plus tan squared, right? So if I put that in, right? If I put that in and go, that's like sec squared all over. So 2 plus tan squared dx. Guys, and I reverse chain rule, right? If I go let, so right now, oh, sorry, not reverse chain rule, substitution, right? So if I go let u equal to tan x, right? Then du dx equals sec squared, and dx equals to du over sec squared, right? Yeah, so I can use reverse chain rule with tan inverse, or just use substitution, same thing, right? Either way, when you sub it all in, it becomes like sec squares go away, 2 plus u squared du. Guys, exactly the same question as before. So that's like 1 on root 2, tan inverse of u on root 2 plus c. And then you have it, right? Tan x on root 2. Let's see. So two neat ways to do this question, giving you the same answer, right? Key result is, I guess, almost like the default, right? Default approach. If you had to use a method where there's trig involved and you have no direction, T results generally is the way to go. Otherwise, in this case, right, cos squared, you know that that's not a nice integral. Sec squared's better. Divide it in by cos squared and you get somewhere. Guys, two nice questions from Coroneos as 100. Hopefully you like that. Like the video, subscribe to the channel, tell your friends. See you guys later. Thank you.